let's turn to some plants. So I'm going to first introduce you to the mimosa, not the drink, but the Mimosa pudica. And this is a plant that's found in Central America and South America, and it has behaviors. And the first behavior I'm going to show you is if I touch the leaves here, you get to see that the leaves tend to curl up. And then the second behavior is if I tap the leaf, the entire branch seems to fall down. So why does it do that? It's not really known to science. One of the reasons why could be that it scares away insects or it looks less appealing to herbivores. But how does it do that? Now that's interesting. Body, we're going to record the electrical potential from this plant right here, this mimosa. And so what we're going to do is I've got a wire wrapped around the stem, and I've got the ground electrode where? In the ground. It's an electrical engineering joke. All right. So all right, so I'm going to go ahead and tap the leaf here, and I want you to look at the electrical recording that we're going to see inside the plant. Whoa, it is so big. I got to scale it down. All right. So what is that? That is an action potential that's happening inside the plant. Why was it happening? Because it wanted to move, right? And so when I hit the touch receptors, it sent a voltage all the way down to the end of the stem, which caused it to move. And now in our arms, we would move our muscles, but in the plant doesn't have muscles. What it has are water inside the cells, and when the voltage hits it, it opens up, releases the water, changes the shape of the cells, and the leaf falls. Okay, so here we see an action potential encoding information to move, all right? But can it do more? So let's go find out. We're going to go to our good friend, the Venus flytrap here, and we're going to take a look at what happens inside the leaf when a fly lands on here. So I'm going to pretend to be a fly right now, and here's my Venus flytrap. And inside the leaf, you're going to notice that there are 3 little hairs here, and those are trigger hairs. And so when a fly lands, I'm going to touch one of the hairs right now. Ready? 1, 2, 3. What do we get? We get a beautiful action potential. However, the fly trap doesn't close. And to understand why that is, we need to know a little bit more about the behavior of the fly trap. Number one is that it takes a long time to open the traps back up, about 24 to 48. The Venus flytrap, again, I've been talking for more than 20 seconds. So we can see what happens when I touch the hair a second time. So what do we get? We get a second action potential, but again, the leaf doesn't close. So now if I go back in there, and then if I'm a fly moving around, I'm going to be touching the leaf a few times. I'm going to go and brush it a few times. And immediately, the fly trap closes. So here we're seeing the fly trap actually doing a computation. It's determining if there's a fly inside the trap, and then it closes. So let's go back to our original question.